All right, I'm going to give some notes since I was not able to be to class on Wednesday night. Sorry, it's a couple days late. I am adding a unit to this just because it's necessary to be able to work with a lot of the angles that they give you. So I'm adding a few problems from Unit 20. So homework Unit 20 will be page 474, 33 through 61, odd, in addition to these other units. This is all pretty easy, a lot of triangle stuff and angle stuff and areas. So this won't take long. This might be maximum 3 15-minute videos. So, all right. So Unit 20 is on something called angular measure or measuring angles, and an angle is made from a ray. A ray is basically a line that has a beginning, or it's called an endpoint, and then it just goes on and on forever in that direction. And on the end point of that ray, we put another ray. And they're both going in slightly different directions. And now this is the end point of each of these rays, but we call it the vertex of this angle. These two make an angle. We call that angle A. We can call an angle anything we want. We can name it with letters. We can name it with degrees. So 20 degrees would be the name of that, the measure of that angle. So the ways that we measure an angle, there are two ways to write the measure of an angle. One of them is just in degrees. And degrees is just basically based on a circle, and there's 360 degrees in a circle, and every 1 degree, so this angle right here would be a 45-degree angle. And so we can write angles in degrees, and there are two ways to write an angle. As a decimal, so you don't have to have exactly 62 degrees. You could have 62.739 degrees, which is not quite 63 degrees. So this is just strictly in degrees. But another thing they do is they take this, and this is all based on our latitude and longitude and directions on our Earth. So this helps airplanes and people locate things. Instead of just having degrees, they also split each degree. The decimal portion becomes each degree can be split up, each decimal part of a degree can be split into 60 minutes, okay, and that's written 60 with a little 1 apostrophe, and each minute is split into 60 seconds. So another way to write an angle, another way to write this is an angle in degrees, okay, as a decimal. And this is an angle in degrees, minutes, and seconds. This happens to be the same angle as this. It's just two different ways to write it. It's kind of like writing 1.5 and 3/2 or 1.5. These are all the same number. It's just different ways to write it. So this and this are the same measure of a degree here. They would look like the same angle, but these are two different ways to write it. And what we're going to learn to do is to translate back and forth. The most valuable way for you to see a decimal degree written is as a decimal. But they do ask you to change from a decimal to degrees, minutes, and seconds, and from degrees, minutes, and seconds back to a decimal. And the main thing you will want to be able to do just to make your life easier is to change it every one that's in degrees, minutes, and seconds into a decimal. That'll just make your life easier. So, and as far as I'm concerned, you don't have to ever put answers after this section, after this unit. You have to do it in Unit 20. You don't have to write them in that form. You can put them all in decimals, but you have to know how to do that. So here's how we do it. So the way we do it, here's directions. These directions are also in Unit 20. So to change degrees, minutes, and seconds to decimal degrees, the first thing we're going to do is we're going to divide the seconds by 60. So I'm going to work this problem out at the same time. So step 1, I'm going to take the seconds part, which is 52, I'm going to divide it by 60. I'm going to do that on a calculator. So 52 divided by 60 is equal to 0.86666. It looks like just 86 repeating. Okay, so now what I'm going to do, says divide the seconds by 60, okay, so, and then add the minutes to the answer from number 1. So I'm going to take this and I'm going to add it to the minutes. So step 2, I'm going to take this and I'm going to add it to 43 minutes. Okay, so that plus that gives me 43 43.86666. Okay, so that was step 2. Now add the minutes. There's the minutes. These were the seconds. Add the minutes to the decimal I got here. Now I divide that sum by 60. So step 3, I divide 43.86 repeating divided by 60. So add 43 to that on my calculator, divide by 60, and that gives me my decimal is 0.731 repeating. So now step 4 says add that decimal to add that decimal degree to the given number of degrees, 78. So that plus 78 is equal to 78.731 repeating degrees. So we start back here. We divide this by 60. We add it to that. So it just basically becomes the decimal. We take this and the decimal of this, we divide it by 60, and that just gets tacked on as a decimal for 78. All right, so now if we want to change decimal degrees into degrees, minutes, and seconds. Okay, this first way is actually going to be the most valuable for you, to get rid of it in degrees, minutes, and seconds, and to change it to a decimal, because this decimal is a whole lot easier for you to type into your calculator. But this is what you sometimes have to do, change decimal degrees to degrees, minutes, and seconds. So again, I'm going to follow the steps and do this example at the same time. So we're going to multiply the decimal part by 60. So step 1, take the decimal part, 0.9276, and multiply it by 60. So 0.9276 divided by 60, or sorry, times 60, not divided by 60, 0.9276 times 60, and that gives me 55.656. Okay, this is the number of minutes. Okay, now, well, only part of it is. This part here is the number of minutes. So I know that this up here, what I'm going to write it's going to be 53 degrees, because that degrees part stays the same. It's just this part that needs to change into the minutes and the seconds. So okay, so it is the, I don't know where, I paused that accidentally. So we have 53, that's the degrees. We found the minutes by taking the decimal part, multiplying it by 60, and just taking the part before the decimal, that's the minutes. We take, this is step 2 now, take the decimal part of step 1, 0.656, and multiply that by 60. So 0.656 times 60, and that gives me 39.36. Round that to the nearest whole number, which would be 39, and that becomes the seconds. So the last thing in Unit 20 that you have to know is what the complement of an angle or complementary angles are. And complementary angles add up to 90 degrees. So complementary angles add up to 90 degrees. Supplementary angles add up to 180. And I guess kind of the way I remember that is alphabetical order, smallest to biggest. So C comes before S in alphabetical order, and 90 is smaller than 180. So the C goes with 90 degrees, the S goes with 180 degrees. That's kind of how you can keep them straight. So they ask you to find the complement of this angle right here. Okay, so basically the complement would be this angle plus the angle I want to know, plus this angle, 73 degrees, 18 minutes, 27 seconds. When I add those together, I have to get 90 degrees. Okay, so here's a case where we have to utilize what we just learned. We want to change this into decimals, because otherwise it's hard for us to do. So I'm going to take this and I'm going to follow the steps that we just had. I want to change degrees, minutes, and seconds into a decimal. So I'm going to divide the seconds by 60. So I'm going to take 27 divided by 60. So I take 27 divided by 60. And so then this becomes 18.45. Add that to the minutes, and I divide that by 60, and divide that by 60, and then I get my decimal is 0.0075. So this, instead of degrees, minutes, and seconds, my actual problem is what angle plus 73.0075 degrees equals 90 degrees. So this is like your equation. Basically, all I have to do to figure out what this is use an inverse operation. I just have to take, this is like x what plus 73 degree, 0.0075 degrees equals 90. All I have to do is subtract the 73 degrees from both sides. You don't have to show the work like I'm doing. If you just recognize, oh, well, if they have to add up to 90 and I know one of them, I just have to subtract them. So on my calculator, 90 minus 73.0075 gives me that the complement of 73 degrees, 18 minutes, 27 seconds is 16.9925 degrees. So now we want to find the supplement of 89 degrees, 57 minutes, 50 seconds. So again, I'm going to do the same thing I did up here. I'm going to change this into degrees, minutes, and seconds. So I'm going to divide this by 60. So 50 divided by 60 is 0.83 repeating. So I have 57.83 repeating. Divide that by 60. So plus 57 on my calculator, and then divide by 60. And that gives me that the decimal of this is 89.9639 degrees. So I took the seconds, divided it by 60, added that decimal to the 57 minutes, divided that by 60, and then what I got there was the decimal. The degrees part stays the same. So now the supplement means this angle plus the angle I want plus 89.9639 degrees has to add up to 180. So all I have to do is take 180 minus 89.9639 degrees. So on my calculator, and that gives me that the angle I need is 90.0361 degrees. Okay, and finally this one's pretty easy. Find the complement and supplement of 19 degrees. So the complement is where they have to, what plus 19 equals 90, and the supplement is what plus 19 equals 180. So all I have to do is take 90 minus 19 here, and the complement is 71 degrees, and the supplement, all I have to do is take 180 minus 19, and that gives me the supplement is 161 degrees. All right, so those are the only two things that you have to know, changing degrees from degrees, minutes, and seconds, and complements and supplements. So now we can move on to Unit 21. This is a pretty simple unit. We're going to quickly go through the different definitions here. So angles, this symbol right here means angle. So I don't write the word angle out a lot. I write that symbol. So an acute angle is an angle that is less than 90 degrees. So it'll always look a little smaller than this, because a right angle is an angle that is equal to 90 degrees, and any angle that's equal to 90 degrees, they'll put this little like square box in the corner to tell you that it's a 90-degree angle. An obtuse angle, O-B-T-U-S-E, is greater than 90 degrees. So it'll look bigger than that angle. A transversal is a line that crosses two other lines. So here's two lines. This is the transversal because it crosses them both. And these next theorems are about the next three, well, the next two are about transversals. So if you have two lines and a transversal, the one with the T is the transversal. Alternate interior angles are pairs of interior angles, so inside the two lines, that means interior, that are on the opposite side of the transversal. So 1 and 4 are alternate interior angles, and so are 2 and 3. Corresponding angles are angles on the inside that are on the same inside of the two lines that the transversal crosses, but they're on the same side. So 2 and 4 are corresponding angles, and 1 and 3 are also. Okay, vertical angles, if you have two lines that cross, vertical angles are the ones opposite each other. So 1 and 3 are called vertical angles, 2 and 4 are called vertical angles. Okay, so some nice things to know about these, and these are some of the theorems that I'll talk about later. Alternate interior angles add up. They don't add up, they are the same. Alternate interior angles are the same. Corresponding angles